Hello guys, in this video, I'm going to take you through the heat value or a calorific value. It's called a heat value or a calorific value. It's of fuel. It's only a fuel that has a heat value or a calorific value. Let's first define a fuel. A fuel is a material that is burned to release heat or power. For example, if you can burn the petrol, the coal, they release heat. But if you can add heat into water or a steel, those are called substances. They don't release heat, but the temperature increases. So I'm introducing you to a second concept called calorific value. Calorific value or heat value has something to do with a fuel. It's of a fuel. But the previous video was about a specific capacity of a substance. Formula of a substance is MC delta T. So in this video, we're going to learn about a new formula of a heat of a fuel. Now, this heat value is the amount of heat energy released when 1 kilogram of a fuel is burned completely. Each and every fuel has its own amount of heat that it releases when its 1 kilogram is burned completely. Similar to a specific capacity, each and every substance has its own heat that it requires for its temperature to increase by 1 degree. Now, the symbol used for a heat value is HV. If you are given calorific value, you can put CV, but it's the same thing as the HV. Units is the heat which is joule released when only 1 kilogram, so it's joule per kg. That is the SI unit. Now, if it releases 30 per kilogram, if you have 2 kg, it means it will be 2 times 30, which is 60 kilograms. How do you get 60? You multiply the given M by a heat value. So the formula to calculate the heat released by a fuel is the MHV. M is the mass of a fuel. HV is the heat value, that heat that is needed or released when 1 kilogram is completely burned. Types of fuel or types of combustibles. They like to ask this question in exam that give 3 types of combustibles and give an example of each. So a fuel is combustible when it reacts with another oxygen, reacts with fuel, reacts with oxygen, there will be that combustion. Now, fuel can be seen as a solid, it can be seen as a liquid, it can be seen as the gas. A solid, these are examples of a solid, a coal, anthracite, wood, coke, charcoal, etc. Liquids, fuel can be seen as a liquid. An example of liquid fuels is petrol, paraffin, diesel, kerosene, benzene, and methylated spirit, and so on. The gases, we do have the gas stoves that uses the gas in order to release heat or energy. The examples, we have the gases, the methane, propane, butane, and a cold gas. Heat value versus the specific capacity. So this is the comparison. A heat value is found in a formula of a fuel, but a specific capacity, we get it in a formula of a substance. Fuel has a heat value. The formula is Q fuel equal to M fuel. So you cannot calculate Q fuel and take M from the substance. It must be also of the fuel. A heat value is of a fuel. A substance is QMC delta T. This M here is of a substance. You cannot take M from a fuel site. And C is the specific capacity of that particular substance. Delta T is the change in temperature. Law of conservation of energy. a law of conservation of heat. When energy is conserved, previous video, it was conservation of energy between substances, where we were saying Q loss is equal to Q gain. Now, the conservation of energy can happen between a fuel and a substance. Let's say you have a coal that is used to heat up water. So heat that is released by coal will be absorbed by a substance. If energy is conserved, there are no losses. So this side will be equal to this side. Under fuel, you put the formula of fuel. Under substance, you put the formula of a substance, and you can solve for the unknown. Heat released by fuel is the heat absorbed by a substance. In other words, fuel is the heat released, and a substance is what is absorbed. Now let's have a look at this. Q fuel is released, it's also a Q released. Also, fuel is required. If a question says calculate the heat required, it means it's looking for the fuel or the input. So fuel is also the input. But a substance, if this one is releasing, the substance is absorbing. If this is required, this one is developed. If this is the input, this one is the output. This is the output. So if there are losses, if there are any losses, losses are expressed in terms of percentage. So we use the symbol efficiency is equal to the output over the input multiplied by 100. So this formula is general formula. It doesn't say output power. It means if we want to calculate efficiency between the heat, it will be Q out over Q in. If it's between the power, it's P out over P in. So this is just a general formula. It is output of whatever that you are calculating over its input. That is the case when there are losses. Now, if they give that 15%, for example, 15% of heat is lost, they are not giving you the efficiency. They are giving you the heat that is lost. So you must use this to get efficiency. If there are no losses, we know that Q fuel is equal to Q substance. It means it is 100%. 100% of what is lost is gained, 100% of it. But when there are losses, 15% is lost, you calculate efficiency and say efficiency is 100. When there are no losses, minus 15, and you get your efficiency as 85%. So when you are given the percentage lost, use that percentage lost to get the efficiency. And then that efficiency, you're going to use it in this formula to work out the efficiency. In not all the questions will be given what is lost. In some questions, they will give you the efficiency as 85%. So if it's given as efficiency, there is no need for calculating, subtracting from 100 because it's already an efficiency. Now let's look at the next slide. I believe it will be the activity. So when the heat is lost, efficiency is output over input and is expressed in percentages. And you don't punch this on a calculator. You just output is less than the input and multiply your answer by 100. You put this as a SI unit of a efficiency. Fuel is the input, substance is the output. Past question paper is April 2022. You are given the 30 kg of coal. So you have a fuel. Type of fuel is a coal. Mass of a fuel is 30 kg. Is used to heat 3,500 liters of water. So the mass of water liters are equal to the kg. So it's 3,500 kg. And the temperature of water, which is initially, is 15 degrees Celsius. Calculate the amount of heat released by the coal. So you are looking for the Q of the coal, the Q of the fuel. Formula to calculate the Q of the fuel is MCHV. Q of the fuel is equal to MHV, not MCHV, sorry. It's MHV. This formula will be given in exam. Mass of the fuel is 30. Let me include the units, 30 kg. Multiply by a heat value. We're gonna get the heat value from the table. Okay, this is the table taken from the past question paper. So heat value of the coal, heat value of the coal is 30. You multiply by 30, it is given in megajoules per kg from the table. So this kg will cancel out this kg, and 30 times 30 is 900. You are left with megajoules. So this heat of the fuel is in megajoules. Second question says calculate the final temperature of the water if the efficiency is 55. So you're not given the heat lost, you are given the efficiency is 55. When you have efficiency, it means heat lost is not equal to heat gain. It's 55% of it. So you use the formula of efficiency to calculate what is the heat of the water. Efficiency is equal to the output, so it will be Q output divided by the Q input multiplied by 100%. Where there is efficiency, you're going to put 55 because it's given as 55. It must be equal to, you have water and fuel. So water is heated by fuel. Water is the output and fuel is the input. So this side, you can put QW or Q out for output. Water is the output. Divided by input is this one, 900 megajoules. So this will be 900 megajoules. Let me just times it by 10 to the power 6 so that you can see your answer will still be in mega. This is multiplied by 100%. So you can cross multiply here. This is over 1. So this will be 55 multiplied by 900 times 10 to the power 6. This would be equal to Q water multiplied by 100. So if you want to get rid of this 100, you divide both sides by 100, both sides by 100. 100 cancels out. Then this Q of water will be equal to, use your calculator to get this answer. It will be 55 times 900 megajoules divided by 100. So the answer will be 495 million. So million stands for 10 to the power 6. So this answer is also in megajoules. Next question. Okay, we're looking for the final temperature of water. We got Q of water. So this Q of water is equal to MC into T2 minus T1. Where there is Q of water is 495. Now this capacity must have the same units, left-hand side must have the same units as the right-hand side. I cannot use 495 and this side use 4187 where there is C. because this one is in joules and this is in mega. So this must also be converted to same units. So it's times 10 to the power 6. And equal to the mass of water is what you're looking for. It was not given. So it's times M. The question is looking for mass of water. No, mass of water was given as 3,500. 3,500. It's temperature that is unknown in this question. Temperature T2 is we don't know. Water was heated at 15 to a temperature we don't know. So T2 is the unknown minus T1 is 15. Now we can multiply what is outside the bracket and bring this one 495 times 10 to the power 6 equal to 3,500 multiplied by 4187. This is 14654,500 into T2 minus 15. Now, since the unknown is inside the bracket, we can just get rid of the coefficient of this bracket by dividing by 14654,500 both sides. 14654,500. So we divide both sides. Divided by 495 times 10 to the power 6. And when we divide it by 10 to the power 6, it will be 33,778 equal to, you are only left with what is inside the bracket, which is T2 minus 15. So when you bring the 15 over, it's going to be plus, and T2 will be equal to 33 plus this, 15 plus 33,778. The answer will be 48,778 degrees Celsius. So this is the answer to this question. I hope it was helpful.